Oh, hey everyone, it's Justin again, just thinking about what I would buy if I had lots of extra money. Now that we've learned so much about exponential functions, maybe we could figure out how to make our money grow exponentially, so we can be rich. Let's find out. In this lesson, we're going to take the knowledge you've acquired about exponential functions and analyze some scenarios that you could encounter in your future. So remember that in order to analyze an exponential function, it's generally best to know its equation, which means we need the function's a value or y-intercept. In a scenario, this could also be its starting value or initial value. And we're going to need the function's b value or growth rate, which is the factor it increases or decreases by as x increases by 1. If we could create the equation, then we can use it to figure out all sorts of things about the scenario and maybe figure out how to make lots of money. So get those guided notes ready and pause here if you'd like to read through them and get a little preview of this lesson. All right, let's get into it. So I've been thinking a lot about my future lately, and I want to do some extra investing to help my money grow. I've really been saving up, and I'm going to invest $10,000 into an account. It will then grow in value or have a rate of return of 10% per year. Remember, when analyzing exponential scenarios, it's helpful to start by creating an equation. Then we can substitute any x value and solve for y, which can help us answer all sorts of questions about the scenario. So how can we represent my investment plans as an exponential equation? There's an initial value and a growth rate. And what do the independent and dependent variables represent? Well, since my growth rate is 10% per year, we'll input the number of years I have the account, and the output will be the total amount of money in the account. Take a moment to create the equation that you think represents this scenario. Did you say the equation would be y equals 10,000 times 10 to the power of x? Or y equals 10,000 times 0.1 to the power of x? What about y equals 10,000 times 1.1 to the power of x? Well, one of these is correct. They all have the same initial value of $10,000, but these b values are all different. If the equation you created is one of these, you might be correct. Let's check each one of these out, starting with this one. Y equals 10,000 times 10 to the power of x. I can create a table of x and y values to help us analyze what this equation means. I'll start my table with my initial investment. Right when I first make the investment, we say that x is 0 because 0 years have passed since making the investment. At 0 years, I have $10,000. I'm not using negative x values like -1 or -2 here because those don't make sense in this context. That would be like time in the past, and I wasn't investing this money back then. Then after 1 year, according to my b value, 10, I should have $100,000? Wow, that means I can make $90,000 more in just the first year? There's no way that's right. If I keep this going, I would have $100 million in 4 years. That can't be right. My investment is supposed to grow by 10% each year, which is only part of my whole investment. Even in just the first year, it should increase by way less than $10,000. So 10 is definitely too large of a b value. I can see that we won't be able to just use the growth rate percentage as the b value then. So although it would be nice if the money would grow 10 times bigger each year, that is definitely not the case in my scenario. So what about this equation? Y equals 10,000 times 0.1 to the power of x. Let's check this out in a little more detail next. Let's create a table for this equation too.
It's almost the same equation as before, but this time I'll use 0.1 as the b value. I'll start my table with my initial investment. At 0 years, right when I make the investment, I have $10,000. I'm going to continue to avoid negative x values here because that would be like time in the past when this investment didn't exist. Then after 1 year, according to my b value, 0.1, I should have $1,000. Wait, where's all my money going? If I continue with this b value for a few more years, I would have $1 in 4 years. Well, that is definitely not what I want. My money is supposed to grow by 10% each year, so the amount should increase, not decrease. This is actually a pretty common mistake with this topic. Do you have any idea how someone could have ended up with this b value? Well, 0.1 is 10% as a decimal. It looks like changing the percentage to a decimal isn't going to work either.
So changing this percentage increase to a decimal isn't giving us the output we'd expect. I would be pretty upset if my $10,000 became enough to buy one candy bar. So this last equation, y equals 10,000 times 1.1 to the power of x, this must be correct. Let's see why.
If we create a table for this, starting with the initial investment of $10,000 and then using the b value of 1.1, we get this. By year 4, my $10,000 will become $14,641. This b value seems much more reasonable than the others we've looked at, but where did this b value come from? Any ideas? Well, if the 0.1 weren't here, and we were only multiplying by 1 every year, what would happen to my money? Yeah, multiplying it by 1 over and over just won't change it. It would stay as $10,000. So if we go back to the equation we had, the 1 in this equation ensures that my initial investment of $10,000 stays in the account year after year alongside the extra money that it earns. Now, what about the 0.1? Well, what's 10% as a decimal again? Yeah, 10% as a decimal is 0.1. So the 0.1 increases the current value by 10% for each additional time period.
And that means this last equation is the correct way to represent the scenario. But the other two equations up here do represent common mistakes, such as using the percent as the actual b value, or changing the percent to a decimal and forgetting to add it to 1. So be sure to keep those mistakes in mind so you don't make them yourself. All right, let's include what we just learned about working with a percentage increase to our description here. If we have a percentage increase, we calculate the b value as 1 plus the percentage as a decimal. Now, what about the other side of working with money? Losing value. We better be prepared for situations like that too. Let's say someone purchases a brand new SUV for $50,000. It'll decrease in value by 17% each year. Can you write an equation that'll represent this scenario? Be sure to identify the variables too. Pause the video and try it now. Did you figure out the initial value and growth rate? What about the meaning of the input and output? Is your answer one of these? Y equals 50,000 times 0.17 to the power of x? Or maybe y equals 50,000 times 0.83 to the power of x? Or did you find that y equals 50,000 times 1.17 to the power of x? These all have the same a value of 50,000, but the b values are all different. So let's figure out which of these is correct. This time, we're working with a decrease in value, which is exponential decay. So do you think the b value should be greater than 1 or between 0 and 1? Yeah, since this is exponential decay, our growth rate should be between 0 and 1. So that means this last equation won't work. Plus, from what we learned a moment ago, the 1.17 would be growth by 17% because we're adding the 17% as a decimal to 1. Hey, maybe since this is decay, which is the opposite of growth, we don't add the percentage as a decimal to 1. We do the opposite, subtract. What would that give us? What is 1 minus 17% as a decimal? Yeah, it's 0.83. So this must be the correct equation. Y equals 50,000 times 0.83 to the power of x. We should include how to calculate b when we have a percentage decrease to our description too. Now that we know how to make an exponential equation when given a percentage increase or decrease, let's try an example problem.
This says Diego's parents help him put the $1,000 he's earned into a special savings account at the bank that earns 4.9% interest per year for the next 3 years. In 3 years, he plans to take the money and use it for expenses when he starts college. What equation can be used to represent this scenario, and how much money will he have in 3 years? So we're asked to create an equation and then use it to figure out how much money he'll have in 3 years. Even though we aren't told to state what the variables represent, it's always a good idea to start with that so we can interpret our answer correctly. So what are the unknowns? Which one is independent and which one is dependent? The independent variable, or input, x, is the number of years that the money is in the account. And the dependent variable, or output, y, is the amount of money in the account, since it depends on the number of years. Okay, now what about the equation to represent this? What can we substitute in for a and b here? 1,000 is the initial amount, and 4.9% as a decimal is, I'll move that decimal over twice so the number gets smaller. Aha!
It's 0.049.
Since the scenario says he's earning interest, his money is going to grow. This means we'll use 1 plus rather than 1 minus. And here we go. This is the equation. Now, we also need to figure out how much money will be in the account in 3 years. Since 3 is the number of years, that can be substituted in for x. Since the b value is a decimal, we can go ahead and type this into a calculator to find the answer. Pause here to find a calculator and solve for the value of y. Be sure to utilize the calculator tips and tricks in your PDF if it'll help you. I have that y is 1,154.32, which is the amount of money. This means that in 3 years, Diego will have $1,154.32 in the account that he could use for college expenses. We've found the 2 things we were asked for.
Whether you're investing money you saved, buying a car, or planning your expenses, using exponential equations to help us with financial decisions, big or small, is something we can do all throughout our lives. Once you've finished up these guided notes and the additional practice in your PDF, you'll get the chance to work through some activities. The choice is yours as to which ones you'd like to complete. Each has some very valuable life lessons, so the more you complete, the better. Then we'll be well on our way to making our financial goals come true. I can see it now.
Hey, hey.